Okay, part A, you'll notice here we've just got linear terms, okay? So it won't be an inequality involving a quadratic. We just simply need to get the x's on one side, numbers on the other side, and then we'll have a range of solutions. Now, because there's a minus 5x, I might be tempted to take that over to this side, okay? And take the 8 over this side. So I'll have 1, take the 8 over, becomes minus 8, less than then x, and then with that minus 5x, when I take that over, it becomes a plus 5x. So I get 1 minus 8, which is minus 7, is less than then, you got 6x there, yeah? And then take the 6 over, so we're going to divide then by that 6. So you've got your solution there. Now you can't leave it like this, right? Because you need to start with the x. So then we'll say then what it actually is. Now if I read that from right to left as it's set out, it would be saying x is greater than minus 7 over 6. So I can write that then proper way around, but of course you notice then the inequalities switched around to represent that x is greater than minus 7 over 6. Now had I done it the other way, okay, had I done it so that the x's are all on one side, are all on the left hand side, okay, I'd have started off there with that minus 5x of course, and taken that x over, so I get minus x, okay. So we could do it like this. So we got the x's on the left hand side, but they're both minus of course now. Less than then, well I've got 8 here, and if I take that 1 over, it becomes minus 1. So then you've got here minus 6x, okay, and then this is 7. Now to get x on its own then, we need to take this minus 6 over. Of course when you take it over, we're going to divide. But what's important, when we divide by a negative number, okay, because I'm going to divide by minus 6, you need to switch the direction of the inequality, okay? So when we divide by a negative, that direction has to switch. And there's your answer, exactly like I've got here, okay, minus 7/6, where x is greater than. So in part B, we've got double bracket, okay, and it's less than 3x we're given there, okay? So of course what I do then is I expand that double bracket, okay, and I get a quadratic. So if I do the firsts there, I get x squared. If I then do the outers, I'll get x. If I do the inners, I get 8x, and if I do the lasts, then I get 8, and that's less than 3x. What I'll do then is I'll simplify this. That's x squared. That will become plus 9x plus 8. And if we take that 3x over to the side, I get minus 3x, and that's less than 0. So then I can put this together, and you'll notice then it creates a quadratic inequality, okay, as follows, there, okay. We can solve this, right? We can actually factorize this to then determine the range of solutions of x such that this quadratic here is less than 0. So there are specific values of x, as I said, so that it makes the whole thing less than 0. Now for that, what I do is, right, we look at the actual situation where the quadratic is equal to 0. Okay, so we say for critical points. Okay, now of course it's not equal to 0 here. We want it less than, we want the quadratic less than 0. But if I just for the moment focus on what happens when it's equal to 0, okay, I can then solve that quadratic. Okay, and then we can go back to our inequality to use the results we got here. So double bracket, okay, here, and we just need to think of, you know, we can write this here if you want, two numbers that multiply to give 8 and add up to give 6. So the two numbers are going to be 4 and 2, aren't they? 4 and 2, they both multiply to give 8 and they'll add up to give 6 if I make them both positive. So that means then I've got x plus 4 is equal to 0, or x plus 2 is equal to 0, okay? And that means then, once I've got that, because you've got two brackets equal to 0, times together equal to 0, so one of them is equal to 0. So that means then x is equal to minus 4, or, it's important you have that word or there, x is equal to minus 2, okay? And you take it over to the other side. Now, what I'm going to do now, I'm going to draw this quadratic, okay? Just a sketch. It's not going to be perfect, it's just a quick sketch. And of course, because it's a quadratic, it's going to be a smiley face. And these points here are what we call, of course, the critical points. Those points are where the quadratic is actually equal to 0, okay? So, you notice we've got both negative values here, so minus 2 and minus 4, okay? So that's where the quadratic is equal to 0. So let's draw the smiley face, the quadratic. Let's turn it around just because it's easier to draw there. And we're going to have it going through those 2 points there. Okay, that'll do it. So this is where, as I said here, where we've got our curve, our parabola, equal to 0. Okay, so it's equal to 0 at these 2 points where we solved it at -2 and -4. However, remember, we want to solve the inequality whereby the quadratic is less than 0. So for it to be less than 0, we want to consider the section here, the region here, where the curve is it's got negative values. Okay, so negative values exist here in these range of x values. So if you think about it, x is going to be between -4 and -2. Okay, so what we can say is x. Okay, if it's between -4 and -2, well, it's going to be less than -2. Okay, right? Because it can't be greater than -2, so it's going to be less than -2, but it can be greater than -4. So I'll copy that inequality here, okay, that I've got here, and put -4 there. So that's saying it's between -4 and -2.